Hello everyone, the theme of this article is Early Matrine Intervention of Gut Microbiota for Type 2 Diabetes Prevention. First is a brief introduction. How matrine influences gut microbiota imbalance to prevent the progression of diabetes remains unclear. We conducted experiments using mice to simulate the stages of diabetes development and matrine intervention. Combined with amplicon sequencing, we found that the gut microbiota of diabetic mice continuously changes with the progression of the disease. Furthermore, differences in microbial community composition and function can distinguish the matrine intervention group from other groups. Muribaculum was generally enriched in the intervention group, while Lactobacillus incerti was predominantly enriched in the diabetes group. These microbes may become new targets for diabetes intervention, providing new insights into diabetes treatment. Based on the time series study, we found that the gut microbiota changes dynamically over time. As shown in result 1, we found body weight increased more rapidly in the HD and MD compared to NC. After streptozotocin injection, fasting blood glucose levels in MD increased significantly and remained high, with oral glucose tolerance test and area under the plasma drug concentration time curve showing similar trends. SCFA analysis revealed a significant reduction in propionic acid in MD, while acetic acid, propionic, and butyric acid were lower in HD. Alpha diversity comparisons showed that the microbial diversity of the HD group decreased over time, while the MD group displayed relatively lower diversity during the mid-stage. Beta diversity also indicated intergroup differences at different sampling points, such groups between the MDA and MDC, HDA and HDC. The Venn diagram showed that the MDA and MDB groups shared few ASVs with the MDC group. Clustering analysis also revealed that the MDA group was distinct from the other two groups. Over time, Bacteroidetes levels declined in HD group but rose in MD group. In the post-sampling stage, MD mice exhibited significantly lower levels of Muribaculum, Paramuribaculum, and Lactobacillus incerti. Microbial composition diverged between HD and MD groups at different time points. High-abundance taxa like acetatifactor decreased in MD mice, whereas Muribaculum and Paramuribaculum showed a mid-stage increase followed by a post-stage decline. Result 2 matrine intervention was shown to lower blood glucose levels, modulate SCFA production, and alter gut microbiota composition in type 2 diabetic mice. Fasting blood glucose during OGTT was significantly lower in HMAT than MD. Valeric acid levels were higher in LMAT than MD, with higher doses leading to lower levels. Microbial diversity analysis revealed that the NC group had higher alpha diversity. Beta diversity showed distinct clustering, separating NC from MD and intervention groups. Phylogenetic analysis indicated that Akkermansia enriched across all groups. Matrine-treated groups were enriched with Faecalibaculum and Lachrymyspora. The Manhattan plot showed that the Kinethrix was enriched in the MD group, with LMAT having a greater effect on its enrichment. Lachrymyspora was more enriched in the HMAT group. The analysis of high-abundance microbes revealed that LMAT helped lower the relative abundances of Acinetobacter and Enterocloster, while the relative abundance of Lachrymyspora decreased with increasing doses of matrine. We allos found in comparison with the NC group, the intervention group showed greater enrichment of Lachrymyspora, Eubacterium, Faecalibaculum. Similarly, relative to the MD group, the intervention groups were more enriched with Taurissobacter and Faecalicatina. In result 3, we found that matrine achieved diabetes relief by regulating specific gut microbiota and related metabolic functions. We observed that the LMAT and HMAT groups showed depletion in functions related to aliphatic non-methane hydrocarbon degradation, while the MD group and the matrine intervention groups exhibited higher enrichment levels of functions such as nitrate reduction, nitrate respiration, and nitrogen respiration compared to the NC group. Functions such as respiration of sulfur compounds, sulfate respiration were lower in the MD and intervention groups. Reductive acetogenesis decreased in the MD group, while matrine intervention helped increase their relative abundance. For microbial networks, the NC group had the most links and nodes. The intervention groups showed higher enrichment in betweenness, clusters, and diameter compared to the NC group. Conversely, the MD group was significantly enriched in edges, clustering coefficient, while the intervention groups were not. Fewer key microbes were enriched in the NC group, whereas the LMAT group showed enrichment of connectors. The key microbes were correlated with the physiological indicators. The correlation heat map showed Roseburia, Acinetobacter had significant positive correlations with weight, whereas Lactobacillus incerti was significantly positively associated with FBG. In conclusion, 1. The gut microbiota in diabetic mice changes dynamically over time. 2. Differences in microbial community composition and function can distinguish the matrine intervention group. 3. Muribaculum and Lactobacillus play a critical role in the matrine intervention mice.